Hey, this is Rez. I run Voxai.com, where we teach VFX through online courses, primarily focusing on Houdini and Nuke. I've been using Nuke professionally in my work for several years now, and it's been a crucial component in all of my projects. I truly believe that only through Nuke you can push your renders a step above and really unlock your potential as a 3D artist. Every compositor knows that some things are faster and easier to do in comp rather than in 3D. So with Nuke, we not only have the power to dramatically change the renders, but we can also increase the speed of our final output by understanding where we can skip certain steps in 3D and do them directly in comp. And so learning and understanding compositing will really provide you with the best results in the long term. I've designed this course in a follow-along manner, so my recommendation will be to go through this course once only by watching the lessons, and then run the course again one more time and also follow along with the lessons. In the case for Nuke, there's really not so much technical understanding around it as, let's say, Houdini. So really the best way to learn Nuke will be by actually using it. All the renders and assets needed to follow along will be provided, so simply follow the link in the description of the lesson to download these renders. And with that being said, let's get started with Intro to Nuke for 3D artists. Before we get started on the actual project that we're gonna work on, we first have to cover a little bit of some Nuke basics like hotkeys and interface, navigation, and so on. Just in case this is your first time using Nuke, I want to go over some of these settings real quick so we are on the same page, but ideally we would like to jump into the main project as soon as possible and get our hands dirty, because really that's the best way to learn. With that being said, when it comes to the main project, what I will recommend is that you first watch a lesson, then rewatch the lesson while following along, and then finally try to recreate everything yourself to solidify the information and reference the course lessons only where you need. So with that in mind, let's go ahead and first we'll create a new comp over here, just so we start from scratch as I explain some of the basics. Now, first of all, we can see that as I open up Nuke, we are greeted with a different interface than what we had previously, and this is because I'm using a custom workspace that I created. So if we go over to workspace over here, we can see we have a few options to choose from, and by default we will want to work in the compositing space. So if I select this one, now we're starting to get the interface that we actually need. So there are basically three main windows that we are interested in the most, which will be the node graph, so where we place our nodes. For example, I can drop down a grid over here. We have our viewer where we preview everything we do, and then we have our properties tab over here on the right. When I select a node, all of the properties for the node will show up over here on the right. Now you can see right away that what I have is a little bit different, and what I did essentially, it's the same windows, but I just swapped them around a little bit so it's more comfortable for me. Essentially, I took the node graph and I placed it over here to the side, so I have the viewer in the middle. Also, the curve editor and the dope sheet, these two windows are also pretty important. These have to do with keyframes, which we'll take a look into a little bit later. So I also dragged these ones over here as well with the node graph and the sequence we don't really need, so I just close this one, and now I can just close this entire, I think this is called a pane, so I can close this pane and I essentially have the workspace that I'm usually using. So I save this as a workspace over here called nodes. This is how I usually start my projects. I open up a new comp and then I select the nodes preset for the workspace and we're good to go. So again, we are in the node graph. We can drop down any node if we press tab, so I can drop down a saturation node if I want. We can see the properties on the right. We can also choose nodes from over here from this window. So for example, we have them grouped per what we're trying to achieve. So if we are working with 3D nodes, we have a 3D node group over here, so I can select this. Let's go to 3D classic. I can drop down a light, so we have this over here, but 99% of cases I'm just gonna go tab, select light, and then just drop this like so, through the tab menu. So we have this on the left over here. Sometimes it's useful if you don't really remember the name of the node. You might want to go, for example, in the 3D, let's say that I want to drop down a cube, but in Nuke it's called a box or whatever. You can find the name, you can look for it in these groups. But again, most of the time you're just gonna hit tab and then just type the first few letters of the node that you want, and you're going to drop it. So let's go ahead, get rid of these, and let's drop down again a grid. And to preview a node, all we have to do is select the node, and we can either hit any number from 1 to 0, so 1 2 3 4 5 all the way up to 0 on the keyboard. So if I select the grid and I press 1, we can see the preview for this grid in our viewer. So this is how we can preview our results. And what's really cool about this, if for example I drop down a ramp, I can preview the ramp with 2, and then I can reference the grid again with 1. We can see we have our 1 input connected over here to our viewer pointing to our grid, and our ramp is input 2. So I can add another one. I can do, let's do whatever, let's do a crop. I can set this to 3, and then I can switch between these 3 using the numbers. So this is really cool. This is right away a huge advantage over After Effects. I've been in After Effects for over 10 years, and it was always annoying whenever you wanted to preview a change. You would have to go and select the layer, toggle the visibility for that layer, or toggle the visibility for the effect to preview with and without. It was really annoying. I'm not sure the latest versions of After Effects, maybe there's some sort of plugin, or they finally implemented hotkeys for this. But just being able to preview the nodes like this is really helpful. We'll cover more about hotkeys as we go, but basically this is how you will navigate through your scene. So for example, in our main project file over here, if I want to preview a certain layer that we're working on, for example, this glow bounce layer, I can go ahead and I can go to the pre-mult result and press 1 to preview this. Or if I want to just preview the GI bounce or whatever, I can just preview my layer and I can do any adjustments on it. And I can, let's say for example, I want to add a grade. So I press the G to add a grade node, and I can increase the gain here to adjust the values. And now I can go to the end of my comp here to our final node, and usually I like to preview this with 5, and I can always reference the final effect with 5. You can obviously choose any number that you want, but now I can go back with 1 and just isolate this layer, and with 5 again I will go back to my final result, and I can adjust the grade and either look through the final result over here, so I can lower this grade adjustment, or I can just isolate this so I can see exactly what I'm doing, and at any time I will press 5 and I can preview the result also in the final comp as well. Really helpful. And this workflow is just something that you'll get used to the more you keep doing it. So 1 all the way up to 0, you're going to preview any node that you want. We have our node graph viewer and properties, and on the properties tab, the default here, we can see that there's a value of 1 here. The default here is 10, meaning that with this value set to 10, we can preview the properties for the last 10 selected nodes at the same time. So I have the properties for the crop node, and now if I double click the ramp to select it, we can also see the ramp properties stacked on top of the crop node properties. And as well, if I select the grid now with double click, I can see the grid properties stacked up. So we can stack up all the way to 10 different nodes, and we can clear these windows if I just close them. But really my preferred way of working, and maybe this is a Houdini thing, I usually want to preview the properties of just one node, the current node that I'm working on. So I set this property value here to 1, meaning that if I select the crop, I just have the crop properties and then the ramp, grid and so on, so I don't have them stacked. Sometimes you will need to see the properties of more than one node at the same time. So I might want to, if I set this to 5 for example, I might want to reference some of the values from the grid into the values of the ramp. I might want to link them up with expressions. In this case, it will be useful to have both of them open at the same time, but 90% of cases I just want to work on one single node, so I will set this to 1. And this is all just to mention that you will probably have this value at 10, and it's going to be entirely your call how many nodes you want to see at the same time. Now, Obviously, we have a bunch of buttons over here. We have our channels, or rather our layers, and to the left we have our channels. We'll look into these as we go. And one final thing before we get started is going to be the project settings tabs. So if I go in the node graph window over here and I click on an empty space to deselect any node and I press S, we can go to the properties tab over here. And really important is going to be the name and the project directory. I don't usually use these, even though I should. So if you set a name and a project directory over here, you will be able to reference the paths with an expression. I think it's root.folder or something like that, but don't really worry about this too much for now. What's going to be really important is going to be setting the frame range. So in our case, for the project we're going to work on, our renders go from 1001, and so this will be the start frame, and our end frame will be 1240. FPS will be 24. Again, this depends on the render, but usually it's either going to be 24 or 30. And for the size format, this will be really important as well to set this to the correct format right from the start. For example, if I leave this at the format that it currently has, which is this 2K Super 35 whatever format, if I drop down a radial, we can see this is nicely in the center of our comp. And if, for example, I deselect the radial, I press S to go back to the project settings, and I switch the format over here, let's do maybe something way different like 8K, we can see now that the radial is no longer in the center of our screen. It's going to maintain the bounds it originally had. We can see if we draw an imaginary rectangle over here that was that original 2K format that we had, it's going to be in the center of this. So it got displaced when our format changed. And this will be the same for a lot of different nodes. So it happened to me a few times where I was working in a lower size format. For example, I was working on some proxy renders, which were 960 by 540, and I was using that format. And then when I switched to the high quality renders and I switched to the HD 1080 format, all of my radials and my masks and rotos got displaced, and I had to manually readjust them. So it's really important that you work with the correct format right from the start. And again, now that I have this HD 1080, which is the format that we need for our renders, so we can keep this format. Now we can see that this original radial that I dropped again is not centered, but if I drop down a new radial, it's going to be nicely in the center of our screen. So this will be about the format, and finally we can talk about the color as well. The default color management here, I believe maybe it's set to Nuke, but for our renders, which are rendered in ACES, we have to set the color management here to OCIO, and you should have in the OCIO config, you should have an ACES option over here, and then here we can select ACES 1.2, and then this will set all of our other settings to their correct inputs. And we are pretty much good to go. These will be the project settings that we need, and these are some of the basics, and really a lot of this stuff will make more sense as we go, and with the next lessons we can start working on our project. So I'm gonna go ahead and delete all of these nodes. We have all of the project settings that we need. I will let's go ahead and save this. So I'll press Ctrl S. You can give this any name that you want, hit save, and with the next lesson we can bring in our renders and start working. The best way to learn Houdini and Nuke is through project-based courses. All of our courses on Voxsite are based on real-world projects created for various clients like Riot Games, Puma, and many more. So if you want to see how Houdini and Nuke is used in production, you can check out the courses on Voxsite.com. So we are ready to start. Let's go ahead and bring in some renders. So to start any kind of composition, we'll have to read in our files. And while I'm in the node graph window, we can press R. So this is essentially, we can also hit tab and place down a read node like this. So I will select read from here, press enter, and then this will prompt a window for us where we can select our file. So I'll go up, and here are essentially the folders with containing all of the renders that you've been provided with in the downloads. And if I click in any of these folders, let's start with the Hero Environment 01. I'll click this folder. Here we can see that we have a sequence. So notice where it says here, so it says intro nuke 02, hero environment 01, and then a bunch of hashtags. These hashtags will represent the actual frame that we are going to read. So if we were to look at this folder in our file explorer, this looks something like this. So it's a bunch of files here, each corresponding for each individual frame. So you will be more than used to this. If you've ever created a render sequence from a 3D application, you will most likely know that the preferred way of working is by rendering out and exporting each individual frame rather than exporting an entire sequence with all of the frames packed into like a .mov file or something like that. You will definitely work with image sequences, and in this case it's going to be an EXR sequence. We're going to talk more about EXRs in a second. And also to note here is that if I just want to import one single frame, I don't want to bring this in as a sequence, we have an option over here. So if I disable sequences, then we can bring in just an individual frame. But usually you will want to bring in the entire sequence. So I can double click to read in our sequence, and then we can see our read node over here. It has a nice thumbnail of our render. And if I connect this to our viewer by pressing 1, we can now see this in the viewer here, and I can go to the beginning of the timeline. I can press play. Now we can see that this is our current render. You will also notice here, as our animation plays, we are loading up this orange bar here at the bottom. This orange bar essentially means that we are storing the results, we are caching the results on our drive, and now we are playing this back in real time. But for example, if we had later, when we have a lot more nodes, this will start to slow down a little bit, so the caching portion essentially. But once this timeline is cached out, so we have this full orange bar, then we are going to be able to preview in real time our results. I can also zoom in on this timeline if I hold right click and I drag it over a region. Now when I release right click, we are going to zoom in on our selected frames. And now when I play the animation, it's going to loop only that specific region. So if I just want to work on an isolated part of the render, then I can do this. And to go back to the full range that we set in our project settings, we can just right click on the timeline and it will select the entire range. On the note for timeline and caching, if I press spacebar, we can zoom in on our render, or rather the window. So if I do spacebar again and I'm hovering over the node graph, we can also zoom in on our node graph as well, and this will work with any window. But specifically this is useful for the viewer. So if I press spacebar here, we can zoom in on our render and we can look closer and inspect our results. And now you might have noticed that our cached timeline disappeared, and only this region is now cached out. And this happens when you are zooming either in or out. We can see that as I zoom back out, we get our cached timeline back. But when I zoom in, so maybe if I zoom in even further, we no longer have this. And this is because Nuke will cache by default at sort of the level of zoom that we have. So if I press spacebar again, and we can also press F to frame in on our render like so, or we can press H and it will try to fit with the bounds of the window. But generally I like to use F. So for example, here we are a little bit zoomed out of our render, and Nuke will try to cache at this size. And this is why when we zoom in, we lose some of that cache, because essentially now we are sort of at a higher resolution. But if we want to have consistent caching, we can turn on this option here where it says full frame processing. And by the way, we can see that as I hover over any of these icons, we have a nice tooltip which tells us exactly what the buttons do. So this is very, very helpful. We can pretty much hover over any property in any node, and we can get a quick description of what that property does. So this is really, really handy. But now essentially, if I turn on full frame processing, this means that now Nuke will always render at the highest quality. So now if I do a cache, let's maybe just zoom in on a smaller region over here. I'll press play so I can cache this. We can see that no matter at what level I zoom in, the cache will remain. So this is very helpful. I don't really have this setting turned on by default, maybe at a later stage in the project I will turn this on, but still it's a very important option to note. So we have our environment render, and let's right away start to have a little bit of fun and start actually compositing. Let's say that I want to add a background to this city, so I will just simply drop down a ramp, and this isn't what we're gonna do for the final project, but this is just to demonstrate. Let's preview the ramp again by pressing 1. This will hook it up to our viewer. I will grab our handles here, so depending on what kind of node you're using, you might have some handles in the viewer. In this case, for the ramp, we can decide where our ramp will be by adjusting these 2 points. So let's maybe undo this, and I will grab the point at the bottom here. I will hold down shift and I will drag it up at the top, so we have this bottom to top white to black gradient like so. And now I want to place this behind our environment render. So we have our render over here and we have our ramp to the right, so I can set the ramp maybe to 2 on my keyboard, so I can cycle between these. So the way we now combine these renders is I can drop down a merge with M. I will also, if you do tab, you can also drop a merge from here, but since you will be using this merge all the time, it's really worth memorizing the shortcut for this, which is M. We see this merge expects 2 inputs, and what we want to do in this case is going to be what's called an A over B operation, where A is our foreground layer and B is our background layer. So this is how I like to remember which input is what. We can think of the B layer over here that stands for background. It's not really the technical definition, but this is just how I like to remember the order of layers. So our background in this case is going to be our ramp, and our foreground is going to be the environment. And now if I preview the result of this merge with 1, we can see our ramp behind our city. So we can also preview this animation now, and everything seems to work. Now the reason this works, if we look in our environment render, the reason this operation worked is because this layer has an alpha channel. So if I select this layer and while previewing this layer I press A over our viewer, we can see this black and white mask that determines what parts of our render will be seen and what parts will be transparent. So our black part is essentially what's going to be replaced by our B layer. Let's say that the ramp in this case is going to be our sky. So wherever we have black, it's going to be the sky. And then the white is going to be our render. So this is how this merge operation knows how to combine these 2 layers to obtain the result that we are after. And there are many different operations in merge. By default, when you drop down a merge node, it's going to come with this over operation. But here we can see that we really have a lot of different operations. So we're gonna go over some of these a little bit more in depth later. And also, if you hover over this property over here, we can also see the math behind how these are calculated. And if you look in this list, you can find over more towards the end here. We can see that it's A plus B and in parentheses 1 minus small case a. Now, don't worry about this for now. A lot of these operations really are going to be done intuitively. So after you get used to compositing in Nuke, a lot of this will just be second nature, and you'll know which operations you'll want without really knowing the math behind them. So really, if I were to tell you without looking at this list how the out operation works, for example, I wouldn't be able to tell you the math, but I know what to expect from it when I use it. So that's what I mean by instinctively. And this is also why I would encourage you to just get your hands dirty as soon as possible and try some of these operations out yourself. There's also a cool property here in this merge node with the mix value. So let's get rid of this one and go back to our merge operation here. We can also determine how much strength we want from our A layer in this case. So if I were to set this to a lower value, we can see how we we start to get more of our ramp and less of our geometries. And this mix property will be present on a lot of nodes as well. So if I drop down a grade node with G, we also have this mix node. And speaking of grade, let's go ahead and again, the shortcut for the grade node is G, and this is also one of the most common nodes you are going to use, so it's worth knowing this shortcut. If I were to drop now a grade after our ramp and before our merge, I can go ahead and gain this down so I can darken our sky, and I can stack multiple grade nodes. I can do another grade node with G, and let's say that I want to make the sky more blue. I will go again to the gain node. We can also affect the gamma in this case, but for the gain node, let's click on these color wheels so we have access to the individual channels, and I will just bump up the blue channel and maybe decrease the red channel, so now our sky is blue. And again, maybe if this is too blue, I want to bring back more of my original ramp. I could use this mix value. Sometimes I do this. I will just lower this mix value, which essentially determines the strength of this gray node over here. So I can just lower this. Maybe I want 50% of this gray node to affect our render, so I will just set the mix value here to 0.5. So sometimes it's pretty useful. So let's bring in our character as well. I'll press R again. I'll go up. Let's bring in our hero character. I will double click on our render and we can preview this with 1. And with this layer selected, I will press M. And this will automatically connect it to our merge node as the foreground layer. So now our background layer, in this case, I want it to be both our sky and our city render. So I will point this B layer to our other merge. And now slowly we are starting to build our comp. And now, for example, I can grab this character layer over here. I will press G. I might want to darken this for whatever reason. Let's drop down the gain, and for our environment render as well, let's go ahead do another grade with G. Let's maybe gain this down as well. We can lower the gamma, and this right here, what we've done so far is a very basic comp, but this is essentially the workflow. From here, it's just a matter of adding more stuff and creating our own layers that we will merge in with the rest of our composition. But this is really the general workflow. And in my case, and what makes sense to me with any kind of comp, is to work from the furthest element back to the element that's closest to the camera, so that's in front. So in this case, we have our sky. This will be our furthest element away from the camera. Then on top of that, we have our environment, and on top of this, we add our character. And now we have, like I've shown you earlier, we have complete control over each individual layer. Now with the next lesson, we'll go more in depth about how we can get the ultimate control with render passes, but this essentially is a very basic composition. So I would like you to try this out yourself with just these 2 nodes for now, or rather 3 nodes, including the read node. So get familiar with the read node and especially the merge and the grade node. Try out to build this very basic composition, and with the next lesson we'll take a look into how we can get even more control and start to take a deeper dive into compositing. So earlier we've mentioned that our sequence is an EXR sequence, as we can see here, .exr, and there's basically 2 big distinctions when it comes to EXRs as opposed to other image formats like JPEG or PNGs. So first of all, with EXRs, we can store from the render pixel values that are over 1. So if we look at our character render, we can see that some of the different parts of the character will have different values. So for example, if I look at the sword, the specularity will have pixel values that go over 1. We can check our pixel information over here at the bottom. As I hover over this sword over here, I can even sample a region. If I hold down Control and Shift and draw a rectangle, we can see that the average for this region is going to be this 4.9 value on all of our channels, so RGB channels. And then over here we have normal values, so under 1, 0.39, and so on. But the important thing to note here is storing this value that is over 1, because if I drop down a gray node and I gain this down, we can also check this. Let's maybe get rid of this gray node, and we can also use our gain and gamma sliders over here in the viewer. So the difference here is that when we do this, we can see that we can gain our image down. When we do this in the viewer, this isn't really applying it to our render, and we can always just get it back if we click where it says this f divided by 20 property over here to reset it to the defaults. So these sliders here are really just to troubleshoot for different areas without having to add a gain node and actually affecting the comp. We can just inspect our renders here, and then we can reset them by clicking on this F thing here and this Y thing for the gamma. So as we gain this down, we can see that we actually preserve some of the detail in the texture, and maybe this is more noticeable here. So if I reset this area over here, let's go ahead and sample this. So this is roughly 6.6, and if we were to gain this down, we can see that we will preserve all of this detail that's in the texture, so all of the scratches and all this nice detail. So a JPEG is different in this sense. JPEG has all of the values clamped to 1. So for example, I could drop down a clamp, and let's connect this to our render. So when we preview this, already we can see something different. All of these pixel values now can't go really above 1, and if I were to do a gray node or actually change the f-stop here, when I gain this down, we can see we have this flat color, so we no longer have any of our details. So this is how a JPEG would work, and this is why these values that go above 1 is important. So when we go back to our actual render, we can see that we can see a huge difference between this. So this is one of the reasons why EXRs are powerful, and the other even more powerful reason is the ability to store different render passes. So most of you watching this are probably familiar with Houdini. This is a Houdini channel primarily. So I will just step over in Houdini real quick to show you how I set up the render passes. So if I do a quick test render here in the viewport, we'll go to our camera. This is actually what we've exported in the render, and over here we have, this is the Karma render settings node, so this is Solaris. And by the way, if you're unfamiliar with Houdini, definitely check out voxsite.com, where we have a lot of free beginner classes for Houdini. So but to keep things short and relevant to what we need, here in this tab we have AOVs. So you will either hear the term AOV or render pass, and this essentially means that we can split up the render in each different contributions, so we can have the specularity different from the reflections, different from the diffuse passes, and so forth. And for example, here is where we can choose what AOVs we are exporting, so diffuse, reflections, and refractions. In this case we don't have any refractions. We can choose lights and emissions. If we had volume, so we can render different effects separately. SSS stands for subsurface scattering, so if we had a character with skin, usually skin shaders have this SSS property, but in our case we don't have this. Again, this is just to demonstrate. And then we have a lot of utility layers. We can export the position in world space, so this is stored again per pixel. Everything is stored per pixel, but if I go to this image planes over here, we can check out the individual render passes that we have, or render AOVs. And also when we export the render from Houdini as an EXR and bring it over in Nuke, for example, our character render and also our environment render will both have the same AOVs, and we can check them. If we go where it says here RGBA, we can actually check our render passes. So we can go to the combine diffuse. We also have this separated per lights, so we have a distant light and a sky and a sun. So we can separate the contribution from the distant light, as we can see here. And again, it's useful to use these sliders here at the top to gain up, and some of these passes might come out really dark, so when you want to check if indeed there's something there, you can just use these sliders here. So we'll have our combined diffuse sky, sun, we have all of the contributions. So this combined glossy reflection, for example, is going to be all of the contributions for all of the lights put together. together, but we are going to separate them per light. So we have the distant one. Let's maybe reset this. So we have the sky and the sun. So having access to all of these layers, when we separate them and put them back together, we are going to come with what's called the beauty, which is the render that contains all of the information, essentially the RGBA in this case. And one quick note about this RGBA here, we can see that we can also preview just the RGB, and when we have this selected to RGB and I press A over my viewport, I can see the alpha channel only if I set this to RGBA. So when I have this RGBA here, if I press A, we can see the alpha channel. So it happened a few times where I would want to preview the alpha channel for a layer and it wouldn't show me the alpha layer, and this is because this was set to RGB. So make sure that whenever you want to go back to the beauty or the default, you set this to RGBA. We can also see that we can just preview the alpha, but this isn't really useful because we have the alpha information here by pressing A on the viewport. So when we bring in an EXR, like we have in this case, by default, it will show us the beauty. And in order to be able to individually affect all of the different render AOVs, we have to split them all up and then put them back together, and this splitting and putting back together of the AOVs is what's called recreating the beauty. So this will be our next step here. We can maybe start with the environment. I'm going to just go ahead and let's Control C, and I will Control V to paste this hero environment render over here and start a new comp maybe on the right. So earlier when I've shown you how we can preview the individual render passes through our viewer here, this isn't really splitting up our beauty. This is really just allowing us to preview the respective render AOV. So if we want to export this render, we would still export the RGBA, which is this right here. So what we need to do is split up each individual layer, and it would be kind of intuitive if we had a node that says something like split AOV, but in this case, to split up the renders, we need a shuffle node. So let's go ahead and press tab and drop down a shuffle, and with the environment render selected, this will automatically append it, and we can see that this is by default placed in the B input. And now here to the right we have our options. So by default we can see that our input layer, which is our B layer, and this is just the default configuration. We can also shuffle in layers from a different render, but in this case what we want is to shuffle one of our existing layers from this environment render into the RGBA layer. So really, all of this is to say that over here we can just select the AOV that we want to expose, and let's say that we want to start with the combined diffuse layer. So we can either choose the combined diffuse without any underscore, but like I said, we would want to separate this per individual light, so we can start with the combined diffuse distant. And we can see now that all of the individual channels, the RGB of the combined diffuse layer are going to be shuffled inside the RGB channels in the output layer. So from this shuffle now, this becomes our new RGB for this shuffle. And now we can do stuff with it. We can add a gray node, we can gain this up, and we can either press M to do a merge, and we can merge this on top of our original render. And if I set this operation to plus, we can go ahead and let's increase the gain here and maybe the gamma. We can see that we are adding another layer of our combined diffuse render pass on top of our beauty. This doesn't really make any sense, but the point is that after we do this shuffle, we can now start using this combined diffuse distant pass that we selected over here. So let's go ahead and get rid of this merge for now. And really what we have to do now, we can also get rid of the grade. So with the shuffle node, what we need to do is shuffle out all of the individual different render passes to recreate the beauty. And for example, if I want to duplicate this node, I can select this node, press Alt C. So Alt C will duplicate, and I can point this back to our render and this new shuffle. Let's go ahead and let's choose our combined diffuse emission. In this case, if we preview this, we can see that there isn't really anything here. So it happens occasionally, especially if we separate the lights per individual contribution, that some of these layers might come in empty. And let's just go to the next one, which will be our combined diffuse sky. So we can see that we do have some information over here. Let's go ahead and reset reset, and we can do, let's do one more for now. Let's do Alt-C to duplicate the node, point this back to our render, and let's do our final combined diffuse, which will be the sun contribution. So we can preview this. And now if I go cycle through all of this, we can see each individual contribution for the combined diffuse split up per its respective light. And now we can essentially start merging these. So I will select the first shuffle, I will press M, I can merge this with my second shuffle, and from this merge I can drop down another merge, and I can combine this with our third shuffle. And I will set this operation here to plus, and I will set also our second merge to plus. And now if we take a look at the result, this will be our combined diffuse, and I can start grading and doing stuff per individual pass. So I can add a grade node, and let's go to our shuffle. This will be our sky contribution. So if I preview the result from our last merge and go to this grade node that's affecting the sky, I can set the gain to, let's maybe go to 0. So now I don't have any contribution from the skylight, and hopefully you can see where I'm going with this. Now, something I like doing with the shuffle nodes, we can go to the node tab. We can see we have a tab for shuffle over here, and most nodes will also have this node tab over here where we can give this a label. So in the shuffle node, we can see that this is the combined diffuse distance. So we can go to the label here and we can specify ourselves what we are shuffling in. So this will be our, let's do diffuse distant, and now we will see this over here in our node graph, so we know which shuffle is which. But another thing that you can also do is we can grab the name that we shuffle in. So we can grab this input name here. If we do an expression, or rather a syntax, so we can do open brackets and we can type value, and we want to read this from the in1 parameter. So here we'll do in1 and we'll close brackets. So now this will give me the name over here, combined diffuse distance. And for example, if we select this one and change this to a different one, facing ratio, we can see now that this says facing ratio. So I will undo this. Let's bring back our combined diffuse, and we can go ahead and copy this value in one syntax over here to our other shuffles as well. Let's copy this to our third one, so we can easily differentiate between these between all of these shuffles. Now we can organize these layers a little bit, because we still have to bring in a lot of other render passes as well, so we don't really want to have a messy organization here. So what we can do, if I hold down Control, we can see that this now creates a dot at the center of each individual wire, and I can click while holding Control to add a dot, and I can rewire all of my nodes like this. So for example, now I can add another dot over here with Control, and I can maybe rewire my nodes like this. And this is how I like to organize my beauty recreation setup. I think this is the most intuitive way, at least for me. So I know all of these merge operations need to be plus. I can maybe add another dot over here so we can see how easily we can start to organize things. If I just want to add a dot anywhere in this space, I can press period on the keyboard, and we can see that this drops down a dot, and we can connect this anywhere. And we'll talk a little bit more about wire management as we start to add more nodes. So let's also get rid of this gray node for now, and let's bring in the rest of our AOVs. So we'll go ahead from here and bring in our remaining passes, and what I like to do is we can just grab a bunch of these nodes together, and I can press Alt-C to duplicate all of them. Then I will connect these two copies up, and so we are on our fourth shuffle now. Let's go ahead and we can bring in the combined glossy reflection, and again this is separated for the lights as well. So we are interested in the distant light, the sky, and the sun. So we'll grab the distant one, and for our next one, let's go ahead and we'll grab our sky. So again, this is the combined glossy reflection. Previously we had the combined diffuse, so we'll bring in the reflection sky, and we'll do one more. I'm going to grab a bunch of nodes and press Alt-C to duplicate. Let's hook up our sixth shuffle, and we'll shuffle in our reflection sky. So if we look at these as well, they look like this. So when we now add all of these together, I'm I'm previewing the final result of our final merge node over here. If we compare it with our original render, I'll press 2 on the render. So now we can see I'm switching between this merge over here at the end and our render. So we can compare these two and we have almost the same result. Something's missing over here. We can see if we check this first combine diffuse shuffle over here, we can see that the wires are actually disconnected. So if we want to connect all of these wires up, so the RGB, we can just click drag on the input layer and drag it over the output layer, and now we have our pass back and we can check our other ones as well. All of these are connected. So now if we preview again the final result from the merge and our original render, we can see we have the exact same result. Now, one thing I also like to do here is reverse the order of this merge operation. So currently the first input is A and the second input is B, and we can press Shift X with the node selected to reverse the order, and this works with merge but also works with other nodes as well. So it's a very useful shortcut to know. And the reason I want this B layer to be the first one and the A layer to be the second one, if I look at this merge result and press D, so D is another very important hotkey which we can use to disable layers. So for example, if on this merge I disable it, we see only the B layer, and then when I press D again to enable it, we have the contribution of our second shuffle. So I will press Shift X on all of our merge nodes over here, so it's going B to A. And now, for example, if I go to the beginning, let's maybe preview the result from our last merge node, and I would disable all of our merge nodes with D. Now I can enable them one by one and see exactly how everything adds up, create our final beauty. And this is very useful sometimes to troubleshoot things. Sometimes you don't know the contribution of a certain layer, so you can really troubleshoot easily if you just disable the layer. So now I can see that this reflection distant light over here is contributing to this part of our render. So this is really the setup for the beauty recreation. Now, how do we know that all of these passes have to be added together? So how do we know that this merge should be a plus operation and not something else? This has to do with the specific render engine that you're using. So this is the way it works with Karma from Houdini, but this would be pretty similar with other render engines as well. So in the past I've used Redshift, and most of the operations in Redshift are also a plus operation. For Redshift, for example, you can check out the documentation, and if we look, we can see here on the AOV documentation that the beauty, if I zoom in here, beauty equals, and here we have all of the different passes and how they should be put together. So we see that we plus the diffuse lighting with the global illumination, with the specular, everything is a plus. And then after you plus everything together, you multiply it by a volume tint. So again, all of these are just render AOVs or render passes. You multiply all of these with the volume tint, and then on top of that, you add the volume emission and volume lighting. Now, in our case, we don't actually have volumes in our render, but it would be the same pretty much for Karma as well. If you don't want to overcomplicate things in the beginning, just remember that most of these render passes should be plussed together. So then finally we have our beauty recreation setup here, and I can go, for example, to the reflection distant pass over here, drop a grade with G, and I can gain this down, so I can remove this if I don't want to. We can add another grade here for the sky contribution, and we can see how overall we're removing some of this reflection. Maybe we have too much reflection from the sun. I can gain this down. Maybe I want to bring in more contribution from the sky on the combined diffuse layer here, and I can bump this up, and we can see already if I look at the final result, and I like to preview my final result with 5, so I will set this to 5, and with 1 I can inspect the current node that I want to. So if I preview now our initial render with our comped version, we can already see a difference. So this is how we can start working with passes, and this is why EXRs are super powerful now. We're barely just scratching the surface of what's possible with passes, and we'll look into more examples as we go. But this is essentially a very basic beauty recreation setup. I'll grab all of these gray nodes and get rid of them. So you might want to get used to this setup because you'll be doing this a lot in CG compositing. Now, before we actually start adjusting all of these passes and grade stuff, there's one more crucial step that we have to take into account, and we can look at this with the next lesson. Now, unfortunately, we can't just start grading right away. There's still one more step that we have to do first, and this has to do with unpremultiplying the layer. So what do I mean by this? Let's maybe just first go to our original example. So here we have the ramp, that's the background, and on top of this we bring over our environment. And for example, if I were to add a gray node here and I want to do, let's maybe gain this up. So we are not really getting that problem yet, but if I were to do some more extreme grading, so if I were to also start reducing the gamma, now we will start to see this very subtle dark edge around our building here, and this is what we want to avoid. So the reason that this is happening is because of anti-aliasing, and really the more extreme our grading becomes, the more noticeable this dark edge becomes. So this is really not what we want, and if we look at our render, we can see that this edge here around our building, this very subtle ramp, is what's causing this problem to happen. So by default, all of the render engines will have this sort of anti-aliasing in order to allow smooth edges so that everything blends a little bit better together. And if we look at the alpha information, essentially what's happening is we are having the RGB pixel values multiplied by this alpha value. So we can see here this very subtle gradient over a few pixels from a full value of 1 to a value of 0, and when we switch over, so if I press A again, this translates over to the edges as well. So when we do our grading and we multiply these values, we can see, if I compare the original render with the grade version, we can see essentially we kind of lose one row of pixels if we compare these two values. We had some color information here on this pixel, and when we do our grading, we lose that information. So what we have to do is somehow get rid of this anti-aliased effect, and we want our RGB values to sort of ignore this gradient created by the alpha. And this is what the unpremultiplication will do for us. So for this read node, I will drop down an unpremult node. Let's go ahead and drop this down. We can see now with this unpremult, we sort of flatten out this gradient. It's kind of working like an edge extend. And really what's happening, we can see this over here, it's dividing the RGB values by the alpha values, and as a result, we get rid of our anti-aliasing. And now when we do our grading, we can see that between these two results, we no longer lose any row of pixels. Now, the problem here is that when we look at our merge, we obviously get a problem where our building is now extended. So if I were to disable both the unpremult and the grade, we can see that our building is a lot thicker. So obviously we don't want this. We want to bring back the smoothness of the anti-aliasing that our alpha provided. So after the grade node, what we can do is premult, right? So this will do the reverse of what the unpremult does. So when we add our premult, now we will get our edges back, and as a result, we can see we have that very thin smooth ramp on our edges. So if I were to grab the unpremult and the premult with shift, we can disable both of these layers, and we can see now that this is the original result that we had with that annoying black edge around the building. And if I enable this, we get rid of it, and we are sort of safe to do our grading however we want, without worrying about having that nasty black edge problem occurring. So really what's happening, this unpremult and premult, is it's just a simple divide and multiply operation. If I were to, let's maybe grab our render, and I'm just going to shuffle real quick. Let's grab the alpha, which is essentially what's happening. So if I hold down and drag a wire from the alpha and hold down Alt, we can connect the alpha to all of our our RGBA layers. So now we have this black and white image across all of our RG and B channels as well. So now if I add a merge node and I were to divide this, let's set the operation here to divide, and let's reverse the order with Shift X. So when you are doing divide or a minus operation, the order here matters, but when you are doing a plus or a multiply operation, the nodes can be in any order, but it does matter when you are doing divide and minus. So we can see now that with this divide operation, we get the exact same result that our unpremult does. So this is really all it does. And then to get our edges back, we can drop down another merge, and we will want to multiply this with our shuffle with this black and white image with the values that we want. And then we can set this to multiply and we get our edges back. And in between, we can do our grading, we can do our safe grading without worrying about this ruining our edges. So really this is all the unpremult and premultiplication will do. Every time you have a layer, whether it's a render or footage with transparency, anything that has an alpha, you will need to do this unpremult and premult business. So it's really important that you are aware of this. This can really ruin renders, especially when you are separating a lot of passes over here. You can imagine that adding up all of these pixel values together, you can really mess up the edges of a render. Sometimes you don't have to do this. For example, if this maybe if this environment render was exported with the sky as well, so now we have the alpha transparency because we don't have any sky. But if this were exported with sky and this alpha information was a completely one color across the entire image, then you probably wouldn't have to do this. But in this case, since we do have to replace the sky and we have to add this environment render on top of another layer, then we do need this unpremult and premultiplication thing to do the proper grading. Now, when we are splitting up the renders, we will need to unpremultiply all of these different AOVs in order to do the proper grading. But the problem here is, for example, if I were to drop an unpremult over the combined diffuse distance shuffle over here, we can see that this isn't working. I can gain this up a little bit. We can see that this unpremult really does nothing for this layer. And this is because by default here in the combined diffuse channel, we are just bringing in the RGB channels from this combined diffuse distance pass and outputting them only to the RGB channel. So if I press A over this shuffle, we don't have any alpha information. So we also need to bring in for each shuffle our alpha information from the original render. So we can do this directly in this shuffle node. We have another layer over here. We can grab the alpha. So we'll grab the alpha, and this B layer is looking at our read node over here, which has our main render. So if I grab the alpha from this render and plug this in our output of this shuffle, now if I press A, we see we bring in the alpha. And if I go back to the unpremult and let's zoom in here and I enable this, now we can see that our combined diffuse distance pass is unpremulted and we can do our grading. So we can drop down a grade from here. Let's reset the gain viewer over here so I can gain this up. I can do whatever adjustment and then I can do a premult to get back our edges. Now, another thing to note here, when you are splitting up the AOVs and doing this unpremultiplication thing, you do want the unpremult to affect each individual pass, but you don't want to do the premultiplication after each individual pass, because what happens is when we add our layers together, the pixel values change. So when we do this plus operation, our edges will change, and when we add another pass on top, our edges will change again. So what we want to do is do just one premultiplication at the end of all of our added shuffles. So I will get rid of this premultiplication now, and we want to do the premultiplication after our last merge node. So from over here, we want to do a premult. The problem what happens here again is that when we add all of these different shuffles together, our alpha, our final alpha from over here will change. So if I press A, we do have the alpha because we are bringing it over from our first shuffle. So we do have the correct alpha in this case, But if this second shuffle, we also will have to bring in the alpha as well. So we'll connect this here and we'll do an unpremult so we can prepare this for grading. So now, for example, if we look at the result, we have added both of these alphas together. So we essentially multiply the alpha by 2. And if we compare this with our original render, we can see that the alphas aren't matching. So what we need to do is, after we merge all of these shuffles together, all of our AOVs together, we need to bring in the original alpha from our main render. And we can do this with a copy node. So we can drop down a copy node, and also the hotkey for this will be K on your keyboard. So this will bring up a copy node. Let's go ahead, and we want to copy from A to B, and we can see that by default we can copy different channels, but by default this will copy the alpha to alpha, and we can see this over here. So we can also maybe copy other channels to other channels, but in 90% of cases this is really used to copy the alpha. We want to copy the alpha from our main render, and I will point this over at this dot over here, and let's maybe add another new dot. So if we follow the chain here for this A layer in the copy, we can see that this will point all the way back to our original render. So we'll grab the alpha from the render and we want to copy it. This B layer should be our merged result. So from our main render to our final result here from the merge, if we look at this result now, we get the alpha that we need, and now we can do our pre-mult after we get the alpha. And if I press A, now we have our anti-aliased edges back, we have that smooth fade over our edges, and we are free to do any grading adjustments that we want. We can gain this up, for example. And also very important, now that we have the proper alpha after this copy node, we can also, for example, let's go ahead and grab this ramp that we created earlier. I will press Alt-C to duplicate all of these nodes. So this is just our placeholder for the sky. But now that we have the proper alpha, we can drop down a merge and we can merge our render on top. Of course, this has to be A over B. We want our background to be the sky. So I just reverse the nodes with Shift X, add another dot over here, preview the final result, and we can check to see if we get any weird issues on our edges. And in this case we do, because we have to unpremult all of these other shuffles as well. This is why we get this black edge still. Now we can either shuffle in the alpha individually for all of these other layers as well and then unpremult them, but we can also just run an unpremult over all of them at the same time. So let's go ahead and drop down another unpremult node. We will connect this here before we do our shuffle, and by default this will work only or on the RGB channels, but we can set this to work on all of the layers. So now if I set this to all, we can check and we can see now that our combined diffuse, all of our passes are unpremulted, and we got rid of all the anti-aliased edges. And now essentially from our shuffle nodes we no longer need to bring in our alpha. I'll set this back to the first version that we had, so the default version, and let's go ahead and get rid of this alpha connection, and we no longer need to do our unpremult for each individual shuffles. Now sometimes usually I like to do unpremult per individual AOV, just because on the rare occasion I might not want some of the layers to be unpremulted. But to keep things simple, let's just run an unpremult application over all of these. So now finally, if I go at the end, let's set this back to RGBA. Now we can finally do our grading, so we can adjust all of these, and we will not have any problems with our edges. We can bump up the sun and we can do some crazy stuff, and we can see that we have the correct smoothness over our edges. And this is now the final piece of the puzzle. Let's go ahead and get rid of the grade nodes. So we unpremult all of the shuffles, then we add them together. After we add them together, we copy back the original alpha from our render, and then we run a premult. And this is pretty much what you will have to do every time with renders. Now another problem that's happening when we run the unpremult operation over all of the channels. We have some utility layers over here. So for example, the position pass and maybe the normal pass as well. These layers, we might not want them to be unpremultiplied. We want to run them over the regular version without this premultiplication. So it will be more important down the line when we want to bring in these other layers that we do a shuffle and we point them back to our original render without the premultiplication. So it's important that we don't connect the shuffle to our unpremult. So it's just something that you have to be aware of. And this is why sometimes I like to run an unpremult over each individual shuffle, just so I know exactly what's happening, and it's easier to keep track of the unpremult and premult stuff this way. But again, to keep things simple, we are just going to use this method where we unpremult all of them at the same time. And now with the next lesson, we can start grading and adjusting this environment a little bit. We can go ahead and let's start grading our environment, and we can just simply start and look at each individual layer. So for example, we can go to our diffuse distant light here and I can gain this up. I can either preview the results from all the way over here. Maybe for now I will just let's disconnect our ramp over here. We are going to replace this with an actual sky in a moment, but let's go ahead and we can grade this up or down. We can affect the contributions for each individual light. So I can start to really experiment. Now, what I'm doing here is not really the proper way of working. You would have to adjust the lighting directly in 3D for the best results, because when we are adjusting this light in Nuke, we are kind of faking a lot of stuff. So really, when we are lowering the diffuse contribution from the skylight, this would affect the reflection as well. So these would kind of go hand in hand, the reflections and the global illumination and all that stuff. And ideally, you would get to as close as possible to the result that you are after directly in render. And I've chosen this render specifically to showcase more of an extreme example of how effective compositing can be, but ideally you would want to make a lot of these adjustments directly in render. Now, sometimes what I do is I get a very crude estimation of what I believe the final result should be. So when I'm look deving and experimenting, I might just throw a render like this with just some of the lights that I know I need, so an HDRI, a sunlight, a directional light, and so on. And I will just fine-tune them like this directly inside of Nuke, because really it's just faster to work like this, so we can see how easy this is. We don't have to really worry about anything 3D. So all of these changes I'm doing here are a lot faster than if we were to do them in 3D. So I can do some R&D and experiment with different kind of looks, and then I can go back in 3D and readjust my lights to match what I came up with in Nuke. Now, this kind of workflow is really only possible when you are doing both the 3D and the compositing, and 100% it's not something that's usually done in production. So usually you kind of want subtle changes only in compositing. You want to nail the result as much as possible directly in 3D. But again, when I work for myself and to showcase the power of compositing, I've chosen this extreme example. So we are going to do some very dramatic changes. Let's move forward now to our combined glossy reflection sky. We can also maybe lower this. I kind of like this reflection sky pass. I'll leave this rather unaltered, and let's add another gray node for our sun, and probably I will want to gain this down. I also want to get rid of a lot of this yellow tint that most of these sun layers will have. So for our combined glossy reflection sun, I can drop down a saturation, and I will just reduce the saturation. Probably I want to get rid of the yellows entirely, and so for the sun I will set the saturation to 0. If we go to our sky, I might want to keep some of this blue color that we are getting from the sky, and let's go to our distant light as well. This should be okay. This doesn't have any color. This is just a simple black and white layer, and let's move forward to our combined diffuse sun. Now really we should ideally use all of our passes to recreate the beauty, but in some cases you might not need need some of these layers at all. So it happens often that I bypass some layers entirely. So for example, maybe I don't really need this distant light. We'll keep all of them for now because we don't really know what we want until we add more layers on top. And really, let's for now just try to normalize the intensity and just try to flatten the colors a little bit. So we'll go to our sky. We might want to bump this up. Let's go to our reflection distant. And here I will drop this down quite a bit. Let's also look at our individual passes. So again, with 5, I will preview the end result. So number 5 is hooked up to this end merge node over here. So we'll go back to our sun, shuffle here. Again, we will drop down a saturation and let's set this to 0. And with this grade node, let's preview the final result, and I can maybe lower this overall. And for our sky, combine diffuse sky, this should be fine. And finally, I might want to lower this as well. We can also maybe for this layer, let's preview the final result. Let's increase the gamma so we don't have this super sharp contrast for our distant light hitting the buildings here. And now we can lower this. So mainly here I'm looking for luminance values, and this is just more of a personal thing, but I like to treat luminance values different from the color values. So in general, if you nail down the luminance, so sort of the intensity of the colors in your comp, it will look pretty good regardless of what colors you are using. So if the value of the color itself is good, then it will look good with any color, regardless if this is blue or yellow or whatever other color. Of course, we are still going to go for something pretty specific, but this is just to explain that what I'm trying to do right now is try to get the luminance values right. Now, it's also pretty hard to tell exactly what we need because we still need to add our character, and in between the character and the actual environment, we will bring in more elements and we'll create our own layers. So I won't spend that much time tweaking the values right now. I'm just trying to get in the ballpark, and then we'll add all of our other elements, and then we'll come back and readjust all of the values for our grade nodes and our saturation. And in this way, we will work non-destructively. And this is really the power of compositing and working in Nuke, that you can still come back to your very first layer and do some changes regardless of how many layers we are going to stack later below our first nodes over here. At this point, we can also bring in our character as well. Now, like I said, between the character and our environment, we have to add a lot of layers, but let's just go ahead and also recreate a simple beauty recreation just so we are used to this idea. And then with the next lesson, we can start working on our layers that are in between. So for now, I will just go ahead and I will copy this node. And again, you can just press R and you can read in the character render from over here so you can open it up. But in this case, I can just copy this because we already had this imported. So here is our character render. So again, we can just drop down a merge node from here, and this can go, so this will be the foreground now, and our background will be this merged result here, and we can see our character on top of our environment. And for this character, we can copy this exact same setup. If we look at this render, we will find, and here this really should have been set to RGBA, so we can also preview the alpha channel. So remember what I mentioned earlier was sometimes when you inspect these layers, you want to go back to RGBA and you select RGB as a mistake, and then you will no longer be able to preview the alpha channel. So that's a common mistake that might happen. And here we can see again that we will have all of our combined diffuse layers split by the same lights. And usually when you have a couple of objects that you want to render separately in a scene, you will want to render them in the same lighting conditions and export the same AOVs for them. But this is what usually happens. Now in reality, sometimes you might not have this luxury and you will have different lighting setups and also different AOVs, in which case your job as a compositor will be a little bit harder. But just to keep things simple for the sake of this course, I'm using the exact same lighting setup for both of these renders and the same AOVs, meaning that now, for example, I will disconnect our render for now. I can grab this entire setup with our unpremult, all of our shuffles, and even all of our grading, and I will just copy and paste this over here, and now I can link up my render to this unpremult, and essentially this will now do all of our operations that we did for our environment. These will now apply to our character. And let's also over here preview the RGB, or again, I selected RGB, but we should have selected RGBA. So right, so we also have the alpha, and now we can merge this on top of our environment render. And if we preview the final result, this is what we have. We can check our edges and see that everything matches. We don't have any weird black edges. Our unpremultiplication was correct. And also we transferred all of our, let's call this initial grading. So we've covered really a lot of steps so far. With just these techniques that we've covered so far, we can really push the renders pretty far. So we can see that if I were to look at my original result over here, let's maybe get rid of our grade nodes and just keep our, essentially our environment and our character. So if we look at this result and we look at our new result, we can already see a huge difference. And now we can come and, for example, for the character, let's say that I want to highlight more of the distant light. I can go here and I can increase the grade here, maybe reduce the gamma so I can push the color on this side of the character if I want. So we can treat them a little bit differently. And now, for example, if we want the character to pop out a little bit more, we can increase the contrast of the character with the background, and we'll look a little bit more into this later when we start to add more layers. But this right here is the very essence of CG compositing, this AOV splitting and then grading them per individual AOV, putting everything back together and then going back and readjusting different layers. And like I said, we are working non-destructively, meaning that at any point I can come back to our environment and I can bump this up if I want to in isolation of the character. And this is also something that's really hard to do. I mean, it's not really hard to do in CG, but for example, if I were to affect the light in my 3D scene, I would also bump the light for my character as well, unless I specifically tell the light to ignore certain objects in our scene. But obviously this is a lot more handy, and it's just quicker to do look dev, so I really prefer a lot of time to just do a lot of this lighting directly inside of Nuke. And like I mentioned, after I figure out what my light setup should be, I can come back in 3D and actually do them over there, if there's time, of course. So this is how we can use the AOVs when it comes to recreating the beauty pass and affecting each individual layer. But really, I'm just scratching the surface with AOVs. There's a lot of stuff that we can do. We can use some of the utility passes like the position and the normals to isolate certain parts of the renders. So in that sense, we can create new layers and new masks from these layers. And that's really when we unlock the power of compositing. So with the next lesson, we can take a look at how we can use some of these utility layers. So I will see you there. So we have all of the AOVs that contribute to recreating the beauty, which are these combined diffuse and reflection. So the diffuse, reflection, GI, all of these, everything that you use to recreate the beauty are essentially the layers that we need to rebuild the beauty. But then we can export a few extra layers that don't directly contribute to rebuilding the beauty, but are still essential in CG compositing. And I just want to give you an example in this lesson with one of these utility layers. So you don't have to follow along. This won't really be part of the main project, so to say, but let's go ahead and let's just copy one of these shuffle nodes, and I'm just going to paste this over here. And the reason that I'm copying the shuffle nodes is because we have this value in one expression set up for us. So if I were to connect this back to our render, let's go ahead, and one of these utility layers will be the normal pass. So we can grab the normal, and I will link all of the X, Y, and Z values here to our RG and B channels. And we can simply do this by dragging over the input inside the output. and we can see that this will make the connections for us. And right away, this is a weird looking pass. You might imagine that there's no way that we can use this in our comp. So if I were to just simply add this on our comp, it would make no sense. But what this normal pass is, we output the normal vector values as RGB values. So we can see here, if I were to isolate this part here, if I were to draw a sample region, we have negative 0.01 on our red channel, roughly 1 on our green channel, and then again roughly 0 on our blue channels. So we can imagine that the RGB channels in this case are going to be our X, Y, and Z values for this specific pixel. So if I step over in Houdini real quick, this is our 3D scene. So we can take a look at our normals, and if we were to look closer, let's say that this vector over here, we can look at our coordinate system over here, and we can see that for the most part, this specific vector is mostly facing the Z direction. So this would mean that it has a value closer to 1 on the Z axis, and then 0 on the X, and roughly 0 on the Y, meaning that in 3D it will have a vector value of 0, 0, and 1 on X, Y, and Z. And this means that in Nuke, this will have, if we think of RGB values instead, this will have a 0, 0, and 1 value on RGB. So it will have 0 on the red, 0 on the green, and 1 on the blue. So it will be mostly blue. And this is in fact what we see over here. If we were to go to our building, we can see that this is mostly blue, and this is because this region of the geometry is mostly pointing in the Z direction. And for our ground, for example, this is mostly pointing upwards, so this will be mostly green, which is a 0, 1, and 0 value in terms of RGB. So red, green, blue, green will have a value of 1, and this is why it's mostly green. Now, this is super helpful for us. We can do a lot with this normal AOV, but this is mainly used to relight scenes, and we can create special kind of masks with this layer. Now, we can create masks with any of the other layers as well, with the world position pass as well, and the depth AOV, and we'll take a look into this later. But specifically for our normal channel, if for example I want to isolate the part of our geometry that's facing upwards, so this is mostly going to be our ground, we can, let's first disconnect all of our values. So I just want to grab the Y coordinate. I want to isolate the parts that are pointing upwards, and I will place this Y channel in our alpha channel. So usually when you want to create a mask, you will be working with the alpha as an output, and I'll show you why in a second. But now if I were to press A, we can see that this is how our alpha channel looks right now. So we have isolated this region of our geometry. So now if I want, we can go to one of our combined, let's look for one of these shuffles here. We can go to our combined diffuse sun, and if I were to drop down a grade node, we can see that all of these color correction nodes, and a lot of these nodes will have an arrow to the right, and if I drag this over, we can see that it starts to say that this is used for masks. So we can point this arrow to our shuffle, and now with this gray node pointing the mask to the shuffle, if I turn up the gain, we can see that we are just affecting that part of our mask that we selected from our normal pass. And maybe we can make this even more obvious, so we can see that we are just affecting the part of the geometry essentially that's pointing upwards. So by default, the mask will look for our alpha channel. So here we can see we can turn on our mask. So if I were to not use any masks, we can see that our grade will affect all of our render. And when we turn on the mask, and the mask is turned on by default, we will look for the alpha channel of our input over here. And this is why I mentioned earlier that usually when you are creating a mask, you will work with the alpha channel. So now if I wanted to, I could go back to our shuffle here. I will press A and I can append a grade node. I can further control this region that we selected over here. Now the grade node by default will work on the RGB channels. So in this case, we just want to operate over the alpha. So let's select the channels here to alpha. And if I squeeze in the gamma, if I lower the gamma, we can further isolate this region here. We can play around with the gain as well if we want. But in this case, since this is a mask, really our values shouldn't go over 1. So I would be a little bit more careful with the gain value here. But with this extra gray node on our alpha channel, which we get from our normal, if we go back to our grade over here, we have further refined our area, our mask selection. So if I were to disable and enable this, we can see that how easily we can just bump up the surface of our ground, for example, and we can see that this affects some of these surfaces over here as well. Now we can get rid of these surfaces if we want by implementing even more utility layers to isolate certain parts. But this is just to give you an example of how we can use the utility layer. So this is one example where we are using it as a mask. And again, this isn't really what we are going to use in our final project. I'm just showing you this to demonstrate the power of utility nodes. So again, a utility node is something that doesn't contribute directly to recreating the beauty, but you can use it to create sort of kind of masks, and you can use them to map different kind of textures, and we'll see this in a second. And we can also use it to create new layers, which we will do in the next lesson. So with the next lesson, let's go ahead and get rid of this grade node and the shuffle. So with the next lesson, we'll take a look in how we can create a new layer with the utility passes. So I will see you there. Let's see how we can use the depth layer to create a new fog layer that we can place between our character and the environment. So let's go ahead, and we might make some room over here with our character shuffle AOV. So I'm just going to drag this entire setup down below, and we can start by grabbing one of our shuffle layers, and I will just copy one of these nodes and paste them down below. Again, we will want to grab one of these shuffles with our value in one expression here. And we'll need to point this shuffle back to our render, and we want to point this to our original render before our pre-mold node, and I'll explain why in a second. But essentially we want to bring in some layers that aren't affected by our pre-mold now. So the layer that we will need will be this depth no AA. We have two versions of our depth layer. Let's first maybe look at our depth extra, and now here we have something new. We just have one input here. So essentially this depth layer is exporting just a float value. This depth layer essentially represents each individual pixel stores a value based on how far or close it is to our camera. So we don't want to create a mask. So if we wanted to create a mask using this layer, we would just plug this in our alpha and use the alpha as the mask. But in this case, we want to create a new layer that we can plus on top of our render. So in this case, I will hold down Alt while dragging this wire and connect this to all of our output layers. In this case, we just need the RGB, but we might as well keep the alpha here as well. We will replace the alpha in a second, so don't worry about this. But now if I were to preview this result, we have this what sort of looks like an alpha image. But if we hover over our pixels here, we can see how the values change here. So for example, if I were to select a region, if I were to sample a region that's closer to our camera, we have a value that's roughly 11. So because we are using the same value over here on all of our RG and B channels, we will have the same value on all of our channels. And we can see currently that this value is roughly 11. And if I were to sample a region that's farther away from the camera, so one of these buildings in the back, if I were to sample this region, we see now that this value is 422. So this is 422 units between this building as it exists in 3D space and our camera. And I can show you this because I have access to the 3D scene. If I were to step inside Houdini, we can see these are the buildings, and this is the building that's furthest away from our camera being right over here close to the origin of our world. Here we can see the camera. So if we were to draw a straight line between our camera that's over here, we were to draw a straight line to that sampled region that we have in Nuke, which is somewhere around on this building, this straight line, we can see our units represented over here on the X and the Z coordinates. So this straight line would be 422 units, and this is what this value here represents. Now currently this depth layer as it is, it's not really helpful for us because we see all of these values that go way beyond 1. So to normalize this value and actually see this distance on our buildings, we will have to use a gray node, and this is where our black point and our white point values over here become extremely useful, because if I set this white point to be essentially, like I mentioned earlier, this is like a remapping operation, so I can set the highest value to be this 422 value. I will set the white point to be 422, press enter, and now we can see this nice smooth gradient growing across our entire render, and the closest objects to our camera will have a lower value, and the furthest objects away from our camera will have a value close to 1. And now in fact we can see that our RGB values become this value of 1 because I set this over here. We can further control this value, and by the way, if you want to change the values in any of these properties, you can set the selection to either of these values, and I'm using the arrow keys left and right to go between these. So if I want to make smaller modifications, I will set the selector here between our second and third number, and I can just use my down and up arrow keys to increase the values. And if I want to make bigger changes, I can place the selector one value before, and I can make bigger changes like this. We can see how the values changes. You can also use the scroll wheel here. And if I want to make even bigger changes, I can set the selector to our first value, and I can use the up and down arrow keys or the scroll wheel, and we can see how fast we can adjust these values. So I might want to modify the second value here, and I can scroll up and down to further refine the gradient here and this remapping operation. So that's just a quick Nuke tip on how you can adjust the values. So now we have this new layer, and really, if we wanted, we could just merge it. So I, with this gray node selected, I pressed M, and this will drop down a merge node, and we can merge this on top of what we have. Now, in this case, we want to plus this on top, so we could use a plus operation, and now we can see a little bit of our render below. But sometimes when you want to add layers together, but you don't want really the pixel values to accumulate, you can use a screen operation instead. So this is what we'll do. Screen is like a clamped version of the plus. So again, when you want a more of a subtle, it's sort of like a soft plus operation, this screen thing over here. So it's another pretty common operation that you might want to use. Now, we're not getting exactly what we want. We do need to modify things a little bit. So this is our depth map, but we want to turn this into our fog layer. We don't really have a background for this, because essentially there were no objects in our 3D scene in order for us to record their distance information from the camera. So we will need to fill in our background ourselves. So we can create a constant, and the constant is like a fill color. It's just a flat solid color, and I will set the RGB values here. I will set this to 1, and now I can merge our depth layer on top. Let's set this, let's connect these two layers, and I want our depth layer to be our foreground and our constant to be the background. So I will press Shift X to reverse this, and now we can see this really cool effect. So now it's actually starting to look more like a fog layer. And if we look at our final result as well, we can kind of start to see how things are lining up. Now, there's a few problems here to address, but the first thing that I want to address is if we look close enough, we can see this very harsh edge on our buildings, and this is coming from our fog layer that we just created. If I were to go to just the render, the composite version over here from our merge, we see we have these nice anti-aliased smooth edges on our building, and when we add our fog layer on top, we kind of have this harsh edge, sort of like the result that we get from the unpremult operation that we do for the alpha. And this is because by default, most render engines, and specifically in Houdini, we render the depth without anti-aliasing, because this is what we need when we are doing bokeh or defocusing effects. So if we wanted to add depth of field to our render, we would need this version of the depth map without any filtering on our edges. And in Houdini, if I were to show this real quick, I will go over to Solaris, and here in our environment render settings, we can see here is where I selected all of the utility layers that we want to export, and we can see that this depth layer by default will use this pixel filter option over here, and we can see how this is set up. Essentially, it's kind of like unpremolting all of the edges, and we can see that the rest of these layers are using a different pixel filter. So this is the default filtering that provides the anti-aliasing and the smooth edges. So I've exported the depth as it is over here without the filtering, and then below I created another custom depth map which is named depth no AA, and it's using the same filtering without anti-aliasing as the other ones as well. So if I go back inside of Nuke, here this depth underscore extra is the default one that Houdini provides, and I have added another one which is this depth no AA, and if I hook up all of these nodes to our RGB channels, we can see now we have a few issues here, but now we can see that we do have this filtering now on our edges. The new problem that's happening here is that we have to unpremold and then premold this around the alpha, so we can see that this problem is really just happening, this black edge is just happening around where we have our alpha. So we will need to bring in on our shuffle over here, we'll need to bring in the alpha that we had from our render, and because this B layer is pointing directly to our render, we can just grab the alpha from this B layer and we can output this on our output layer. So now if I press A, we have the correct alpha, and we can do an unpremold. Then we will run our grading, and then we can do a premold, and we'll have the correct edges when it comes to the alpha, but also the correct edges when it comes to the separation of objects inside this entire alpha space. So if I were to preview the result now, we no longer have any weird edges anywhere in our render. So while I'm recording this, I realize there's a lot of annoying stuff to do with these edges, with all this pixel filtering, with all this anti-aliasing, but really after a while this will just become second nature. I'm only realizing how annoying this can be as I'm explaining things, but when I'm actually comping myself and I'm just going full speed, I don't even realize just how annoying some of these edges can be. But sometimes they can be annoying if for some reason you just can't get the edges working right. There is also a dilate node which you can use. Actually, it's called erode. So if I drop down an erode node, now it says when you place this down, it says dilate, but you have to find it by typing erode. So it's a little bit weird. But this dilate, what this will do, it will just push out the pixels one row, so we can increase the size here, and and we can see what happens. We are just expanding the edges, and we can also contract the edges. So if for some reason at any point you end up with some weird edge issue that you can fix, you can always just place down an erode node, and you can either dial in maybe a value of 1 or 2 or increase the size to try to fix that problem. But in this case everything lines up, so I will get rid of this dilate, and we can come back to our final result over here. Now after this merge operation, I will want to drop down a grade node with G, and let's say that with this second grade node here, we can just control the overall strength of this fog layer. So I will just drop this down slightly. And one other thing that happens here, if I preview this from our merge, we can see that this building in the back is a little bit brighter than our background, so our constant, which doesn't really make sense because we want this constant to really be the brightest spot in our fog, because it's essentially the furthest thing away from our camera. So this is way out in Z space. So what we can do here after our grade node and before our premold, we can drop down a clamp as well, and this will make sure by default that no values will go above 1. So now when we add this together, we can see that this building here in the back completely fades off into the distance, and we can go back to our grade node and we can further control this. So maybe we want to reduce this a little bit. So I will just push the highest value, the white point, out a little bit further more. So I can increase the value here to roughly 500. And maybe this provides a better result. Again, we can preview this from our final result over here. And now with this gray node, we can also control the gamma of this transition. So of this gradient in Z space, I can drop down the gammas to make this a little bit more obvious. And maybe actually I will want to lower the white point. I might want this building here in the back to be brighter a little bit. And we can already see with just this extra layer that we have instantly a lot of depth to our scene. And this really helps us to quickly see the space that we are in. And it creates this nice separation between our buildings. And we build this with just a few nodes directly inside of Nuke, which is really great. Let's maybe add another dot over here. And actually I will reroute this wire here for our shuffle. I'm just using Control to add a few dot nodes, and maybe I'll drag all of this setup. I'm holding down Shift to select extra nodes, and we can just drop this down below. And finally, one more thing that we can add here. So we have this gradient that's going across our Z space essentially, but we can also introduce a gradient that's going on the Y space, so vertical gradient. And we can do this very simply in this case by just using a ramp. I will throw down a ramp. Let's reverse the nodes over here. I'm holding down Shift and I'm just trying to create this vertical ramp. So now we can just drop down a merge and we can multiply this over our result. So when we do this, we can see this is what we get, and we can very quickly bump up the detail even more. Let's maybe go to our gray node over here and just increase the gamma. So we push out our fog into the foreground more, and now we can preview our result, and this is it. So let's maybe this grade node I'll place below our ramp just so we have this sort of like global strength of our ramp. We can still play around with the gamma here as well, maybe lower the gain. Now we'll have to introduce our sky, so we will come back to this fog layer in a second, but this is more or less how you can very quickly, very easily set up a fog layer. From here we can control how further away in space we want this fog to be by playing around with our black and white points. So there's really a lot of stuff that you can do with this depth map, and like I said, usually it's used to create defocusing effects, but I really like to use it to isolate certain parts. So I like to use it in this case to create new layers like a fog layer. I like to use it to grade certain stuff. I usually like to darken stuff that's closer to the camera, and maybe we'll do this in a second as well. And with this vertical ramp, you always want to think of different ways in which you can break up your layers and add more detail and contrast to your layers. One more thing that we could do, and you don't have to follow along with this part, we could also break this up even more, and this is really how you should do fogs. You can add a noise, and we'll look more into noise a little bit later, but this is just a noise pattern essentially. We can also multiply our result with this noise, and now we can start to see, I'll add a gray node here and just gamma this up, and now we can really start to see some nice breakup, and this looks this works extremely well with fog layers like we have over here. The problem with this noise is that this is a 3D scene, so the camera is moving, so this noise pattern will not follow. And in this case, we might have to create a 3D layer. So in our courses on voxeye.com, in some of the courses, we create this noise as a volume directly in 3D and export this and export it as a render. Or in some courses, we create this directly in Nuke with a particle system, just so this noise follows the camera and it's actually spread out in 3D space. So it doesn't work in this case with just this simple 2D noise layer. And I think for a beginner course, it's not really worth going into particle systems and all of that right off the bat. So I don't want to really overload you with information, but just as an example, that's this is some of the stuff that you can do to create this breakup. You always want to think of how you can break up the layers even more and add more details. So this will be our fog for now. We can select all of the nodes that we have over here. Maybe we can select them with the dots, and if if I do tab and drop down a backdrop, this will now create a backdrop for us. This is strictly for organizational purposes. We can spread this out a little bit. We can double click here. Inside the label we can do fog, and I usually like to set these backdrops to be darker and more desaturated. So we have our fog layer here. We'll do a backdrop over our other setups as well for the environment and our character, but we'll have to add a few more stuff first. But for our fog, we are pretty much done. Like I mentioned earlier, we'll have to come back to this after we add our sky and some of the other elements. So with the next lesson, we can take care of our sky. So I will see you there. So we can use the AOVs to adjust our already existing render. We can use the utility passes to create our own layers, and we can also create layers by using Nuke's 3D system. And we're gonna do a brief introduction with Nuke's 3D system. It's if you're coming from a 3D application, this will be very familiar to you. Now, Nuke's 3D system isn't really as powerful as an actual 3D application, so you can't really model things. You can adjust already existing models. You can do certain types of transform operations and soft transform, but really it's mostly here to help us place certain elements in our scene. And in this case, what we want to do next with this lesson is place a 3D sky that moves with the camera. So currently, if we were to bring in our sky, so I'm gonna press R and I'm gonna bring in an HDRI in this case. This would work with just a regular image of a sky. In this case, I'm using an HDRI, which we got from Polyhaven. So you will have the link if you want to use the same sky as me in the lesson description. Now with this, we can drop down a gray node and we can gain this down slightly. And we can't just really merge this behind our environment. So over here we have our environment. If I set the background to be our sky, first of all, we see we run into a problem where our resolutions no longer match. So our overcast sky over here, we can see we are using this resolution. So in this case, we would have to use a reformat node. And because we set our project settings, so when I press S without anything selected and go to our options over here, because we have set this to 1080p, our reformat by default will resize our footage or whatever we bring in to this 1920 by 1080. So now when we do our merge, this is going to work. Now if we just render a few frames over here, we are automatically going to see this problem that our geometry is moving. So our camera is moving, but our sky is static. So we need the sky to follow the camera. Now, we are going to use the 3D system for this. I'm going to, let's maybe just disconnect our sky and I'll remove the reformat and the gray node and just keep the sky over here for now. While I'm over the viewport, if I press tab, this will now switch over to this 3D view, in which if I hold down Alt and left click, I can navigate around. I can hold down Alt and right click to zoom in and Alt and middle click to pan things around. So it's really exactly like in most 3D applications. I believe somewhere in the project settings, let's go to edit, somewhere in the preferences over here, you can change how the navigation controls work if you are used to other hotkey combinations, but I'm just using Alt, left click, middle click and right click to zoom in, to move around and navigate in this 3D space. We have some options over here. We are not going to look into this right away. What I want to do is just give you a very brief introduction to how the system works. So let's say that we want to place a card in our scene, and we will do this in the next lesson. We are going to actually place our smoke cards, but right now let's just go ahead and place down a card. So you can see that in between brackets this says geometry. So this is what we want, and we can see this now in our 3D space. We can use a texture. So over here where it says image, we can append a texture, so we can point this to our sky, and now our sky will be mapped to our 2D card. We can also use any other image. We can also use our footage if we want. We can see now that the render is mapped to our card, or we can a lot of times you will have to use let's drop down a noise draw. So we can use a noise texture for our card. And now with our card selected, we see we have the gizmo here. We can use W, E, and R to move, scale, and rotate. So W, E, R, just like it would work in a 3D application. So we can push this further into Z space. We can scale this with R on individual axes, and we can rotate things around. And now if we wanted to use this in our comp, if I press tab again, we don't have anything showing, and this is because we have to render this from the 3D engine sort of to our actual comp, our 2D comp. So to do this, if I press tab again to go back to our view, we can drop down a scanline render, and over here we have two versions, and we are going to use the 3D Classic. We are not going to use the beta versions for now. Let's just use the 3D Classic versions of all of these 3D nodes. So let's drop down a scanline render. And here we have a background, an object or scene, and a camera. Now we don't have a background in this case, we don't need one, but our object in this case will be our card. So I'm going to move this over to the right. And by the way, if I hold down Control while I have a node selected, this will grab all of the nodes above it as well. So this works with any nodes. If I want to select this node over here, we can see all of the connections that we have with this node. So if I hold down Control while I'm dragging this around, it will grab the entirety of the nodes above it. So it's sometimes very useful for organization. Now we have our card. So if we go back to our scanline now, with just the card connected to our OBJ, if I press tab now, we actually see our card over here. By default, this will create a camera for us, even though we haven't specifically created the camera. It will create a camera for us that's right at the origin, and it's facing along the Z direction. So if I were to drop down a camera, again we will use the 3D Classic version, we can see that this is the camera that we create. So we can now hook the cam arrow here to our camera, and if I go to our scanline and I press tab, we can now grab our camera, and inside the camera settings here we can use our translate, rotate, and scale to move the camera around. So I can bring the camera back, and we can press tab and see exactly what kind of transforms you are doing. We can use the gizmo as well. So I press W and we can grab the camera, rotate this around, and if I press tab, we can see how our render essentially changes. So we can adjust the camera through our settings here or directly in the 3D viewport. Now obviously in this case we are going to read in the camera that we export from our actual 3D scene. So we don't have to set the camera here. We can just select read from file, and we are going to bring in this cam01 USD file. And now if I press tab, we can see our camera is all the way over here, and this will be placed exactly where it's placed in our 3D scene in Houdini as well. If I go back over here, we have our camera. We can see it's this camera here. And when I go over back inside of Nuke, it's again going to be over here. So now with this card selected, I can press W and I can push this around. I can bring this up, and I'm going to try to place this roughly somewhere where our camera can see it. I can increase the uniform scale here. And when we go back to our render, let's maybe just make this a little bit smaller. Now this will follow our camera. So essentially this is an element that we can now use in our composition. So from our scanline render, if we want, and this is something similar that we will do with the smoke cards later, we can just do a merge with M and just place this here on top of our render. Now currently this doesn't look like anything, but we can see that it's following the camera and it's nicely integrated with our 3D system. So let's get rid of this merge, and in the case for our sky, we don't press tab. We don't really want a card, although we could use a card and just push this back into 3D space like so and just make this bigger, sort of how we would do it in a regular 3D scene. But in this case, it's better off if we use a sphere instead. So we will drop down a sphere, and here we can see our sphere is really small, so we want this to be huge in order to encompass our entire geometry. So I'm going to push out the uniform scale by quite a lot. Let's try a value of 100, and now we can see our sphere, and we can get rid of our card with the noise. And for the sphere, again, we can just map any texture that we want. And in this case, we will map our sky HDRI. So we can point the image to our sky and we can see our sky nicely mapped to our sphere. Now this sky is 4K by 2K, so we don't really need to use this much resolution for the sky. In fact, I want to lower this by half. So if I drop down a reformat node after, by default this will look at our root format, which is 1920 by 1080 again. But in this case, I will just set this to scale and I want to specify exactly how much I want to scale this. In this case, I will scale this down by 50%. So if I set the scale to 0.5, this will now give me a 2K by 1K value. So when we map this onto our sphere, because this is placed all the way in the back and we are covering a very small part of our screen and we have a bunch of elements on top, we don't really need that extra resolution from a 4K map, and this will just improve our performance a little bit. So now we can use this. We'll point the object scene from our scanline render to our sphere, and if I go to the scanline and preview this and hit tab, now we can see our sky will follow our camera. If I just load up a little bit of this animation, let's take a look. All right, so now we can use this layer here, the scanline render layer, as our background, and finally we have a sky in our render as well. And after the scanline, we can do any changes that we want. We can also do them directly on our texture as well. So either we add a gray node after the scanline and drop this down, maybe decrease the gamma a little bit, or I just do a gray node after our reformat. So before we map this texture onto our sphere, we can also affect the grading here. In this case, maybe we can just use the grading after the scanline. So I can drop this down slightly, and this is looking fairly decent. We can rotate the sphere if we want to get a different part of our sky onto our render. So if I go to the sphere here, I can choose the rotate Y value here. I can just use the scroll wheel. Maybe let's try to find a different part or rather area of our sky. So this is exactly how it would work if we were to use a HDRI inside 3D directly. But really in this case, I would use a 3D projection of the sky. Now I don't really want to get into 3D projection because it might be a little bit beyond a beginner course. I feel like a lot of these things that I've already covered are maybe slightly beyond an introduction course. So I want to avoid getting too deep into some of these techniques, but with a 3D projection, for example, in our Ultimate Effects workshop on Voxlite.com, we used a 3D projection to manually place cloud lining textures between clouds to decide exactly where lining can happen in the sky. So you can get pretty advanced with some of the stuff that you can do with a 3D projection and with the 3D system in general. But to keep things simple, let's just keep this as it is right here. We are just using a texture, mapping it onto a sphere, and then bringing in the camera from our 3D scene. We have our sphere linked up to our scanline render, and then this is basically a very simple sky replacement technique. We should probably also preview this from our fog layer as well to better judge how our sky should look. So now I can go back to our grade. Maybe I can bring this up or down and I can play around with the rotation Y of our sphere, and I will leave this up to you. But one final thing that I would like to touch up on is if we go back to our 3D view and we hit tab, first of all, sometimes you might want to display multiple different settings here. So when I'm dealing with 3D, I will set this value to maybe 5, just because if I were to just have one over here like I usually do, and I would select the sphere and preview just the sphere, we can see that now this no longer shows us our camera. And now if I select the camera and preview the camera, we no longer see the sphere. So to fix this, we can set this to 5. And now if I were to select the sphere and preview the sphere, we also have the camera showing as well, because we have the settings of the camera opened over here to the right. So all of this to say is that sometimes if you have a hard time dealing with the geometry in this 3D system and you want your 3D geometry to show up at all times in this 3D view, just make sure that you are not using one over here as your displayed settings. And one more thing about this sphere technique to replace the sky, we don't really know exactly how big this sphere should be. This sphere should really be all the way in the back of our geometry. So at the very least, it should be way bigger than the building that's furthest away from our camera, but we don't really know where that building would line up in 3D space. And this is where we have a node that's called position to points. So if we hook this up to our main render over here, I'm just going to use this dot from over here that essentially points to our, in this case we can look at our unpremulted layer, doesn't really matter, or let's just maybe point this to our render for simplicity's sake. So this position to points node is pointing to our render, and inside here let's set this back to, or actually let's just keep this at 5 because we are dealing with the 3D system. We can set this surface point, we will set this to look at our world position, which is going to be this P layer. And now when we do this, let's go ahead and just preview this layer. So in this case, I'm going to go ahead and set this only to 1 because I just want to focus on this single layer. So in some cases, it's actually better if you just set this to 1 because you want to isolate your 3D object that you're working on. Anyway, our position to points, this is a really cool representation in 3D space of our render scene. Basically, what this does is it's spreading out all of our pixels from our main beauty render, so from the RGB channels. It's arranging the pixels based on their world position value. So if we were to press tab and just look at our world position, so I'm going to look at our render and set this to our P value, we can see that as I hover over the pixels here, if I just sample this region, we can see that this surface of the building has a coordinate of 52 on the X, 17 on the Y, and -73 on the Z. So this is how our position to points knows where to place our pixels in the 3D space. So if I go back to the position to points, we get this really cool representation here, and it's super useful to troubleshoot your 3D objects and to know where you should place, because now if I set these properties here, let's increase this to 5 so we can also see our sphere. If I also select our sphere, we can see that it's actually not entirely covering up our geometry. So like I mentioned earlier, this sphere should be at least as big as our furthest away point in our geometry, so it should be way beyond this building here in the back. So now that I have this 3D representation, I can simply increase the uniform scale as much as I need to. So I will set this to maybe 1000 just to make sure that this is big enough. So if I preview this now in 3D, we can see that this is more or less where we should place the sky in relation to our building. So now when we go over to our merge result over here, let's set this back to RGBA and Control Shift click to get rid of that sample region. Now we will know for sure that the movement of the sky is correctly matching the movement of our 3D scene, because for example, if so currently our sphere is set to 1000. If I were to set this back to 100, we can see this changes a little bit, and this will mean that our sky is going to move way too much in relation with our geometry, and it really won't feel, when you preview this animation, let's maybe just render a few frames, it really won't feel like this sky is way beyond our geometry, so pushed in Z space. I'm not sure how noticeable this will be, but we can kind of feel it that the sky is a little bit flat. There's really no parallax happening here, and if I set this uniform scale back to 1000, this will now, our sky should move a little bit slower than our geometry. Again, I'm not really sure how noticeable this is. It's probably not that noticeable, but this sort of thing is really important, especially with the next lesson when we look into setting up our 2D cards for the smoke. This will be extremely crucial that we place them in the 3D world exactly where they should be in order to do the proper compositing. So for now, at least we are pretty much done with the sky. We are going to leave this position to points over here because we'll need this in the next lesson. But for now, let's go ahead and just grab all of these nodes, drop down a backdrop, and let's go ahead, rename this label here to sky, and also just darken this a little bit. So this will be our simple sky setup. Again, we might want to preview this from our result with the fog as well. And if we compare the renders, again, we are really starting to see a big difference. So with the next lesson, let's take a look into how we can add our smoke cards. So I will see you there. Now that we are familiar with the 3D system, we can work on our smoke cards. Let's go ahead and we have to read in our smoke footage. So I'll press R and let's bring in our hero assets _ smoke, which looks something like this. So this is just a simple render I did. It's a simple smoke simulation in Houdini, and rendered it in sort of a flat lighting so we can use it in multiple different kind of situations and let's say lighting conditions. When you want to create this sort of layer that you want to use as an element as part of your composition, you want to avoid super strong directional lights or very harsh contrasts in your, in this case, smoke. So we would want to avoid having like a let's say a directional light that's heavily skewed in one direction, because if we keep things flat, this would allow us the greatest flexibility in order to blend it in any lighting conditions that we have with the rest of our comp. So from this render here, we have to map this to a card, sort of like we did earlier. So let's reset our timeline. We can also see here that our timeline is now going from 1001 to